Autonomous vehicles pose a massive commercial opportunity that is attracting the world's top players in transportation and technology. Notably, technology companies, not automobile companies, have taken the lead in commercializing autonomous vehicles. Lewandowski started a company that developed the camera technology that Google, at least initially, used for its Google Maps Street View. In 2007, Google recruited Thrun to head up its nascent self-driving car initiative. In 2008, the Discovery Channel asked Lewandowski's company to build a prototype of a self-driving pizza delivery truck that successfully navigated a journey over the Bay Bridge in San Francisco. At least partly based on this successful pizza delivery, Google purchased the company in 2009. In 2016, Google spun off the self-driving vehicle project into a separate company named Waymo that is owned by Google's parent company Alphabet. Waymo is one of the leaders in the development of self-driving taxis and trucks. Uber hired 40 researchers away from CMU in 2015 by doubling their previous salaries and offering hiring bonuses. In 2016, Lewandowski left Google to start a self-driving truck company named Otto. Later that year, Uber purchased Otto for a little less than 1% of Uber's stock, which was worth a reported $680 million, and put Lewandowski in charge of Uber's self-driving research. Tesla has also made a great deal of noise in the self-driving car space via its autopilot mode, which, despite the name, currently requires the driver to keep their hands on the wheel and to be ready to take over at all times. Although independent technology companies have led the charge, the major car vendors had also done some experimentation with self-driving technologies. For example, Mercedes-Benz funded the Prometheus project in 1987. However, the independent tech companies had the technology and made the first substantial investments. The major automakers quickly followed the technology companies into the autonomous vehicle fray, and virtually every major automaker is making significant investments in the technology. Many are working together to offset the massive costs of development. GM and Honda are collaborating via GM's Cruise division. Ford and Volkswagen formed Argo AI. Bosch and Daimler teamed up. Nissan, Renault, and Microsoft are working together. Many other vendors around the world, operating independently of other automakers, are working on autonomous vehicle technology. How self-driving vehicles work. Self-driving technology starts with sensors that provide the car with information that enables it to adapt to its environment. Some can also communicate with other vehicles on the road so that they can network, for example, to avoid collisions. Finally, all that sensor and communication input must be processed somehow and turned into driving decisions. Sensors. Autonomous vehicles use 4 types of sensors to see other vehicles, pedestrians, lane markers, and other elements of the driving environment: cameras, radar, LiDAR, light detection, and ultrasound. As an example, as of January 2020, Tesla vehicle equipment includes 8 cameras, a forward-facing radar unit, and 12 ultrasonic sensors. Cameras have the best resolution among the vision sensors. They are the best type of sensor to provide input to deep learning systems for lane detection and traffic sign recognition. Infrared cameras, which will start to become available on cars in 2021, can work outside visible spectrum light and can detect lane markers, pedestrians, bicycles, and animals at night. Cameras are also the only type of vision sensor that can detect color, which is important for distinguishing traffic lights and emergency vehicle lights. However, cameras struggle with wet roads, reflective surfaces, and low sun angles because the light reflections obscure the images much like they do when taking a snapshot of someone with the sun directly behind them. One other important difference between cameras and the other sensors is that machine learning is required to interpret the pattern of pixels captured by the camera. In contrast, the other sensors directly provide information about the distance between the vehicle and various objects. Other types of sensors work by sending out signals and analyzing the echoes caused by objects in the signal's path. Radar works by sending out a radio signal and measuring the time for the return echo. It has the most extended range and has the added advantage of being the least expensive. It is also effective when visibility is low, like at night and in fog,